Good morning and welcome to Data Center. In the last class, we considered forecasting and threat detection. All these are under time series. So we want to move on to the next one. So we're going to look at seasonality. We're going to look at how to detect anomalies and then decomposing time series respectively, time parameters, autocorrelations, and smoothing. All right, so you open your I usually do this the ANA the search bar, and then you open the Anaconda PowerShell prompt. You double click. Okay, I have to open. Okay, so we're waiting for it. All right, so if you see my screen, you notice that uh, the directory here is users, of which that is not what my working directory is on the desktop. So I'll change to CD desktop. Click on enter. CD, the name of my folder that I'm working with is Python. Then I can set to clear screen CLS, and then I can then open my Jupyter notebook. So wait for Jupyter notebook to open on the browser. We have Jupyter notebook open. You can see our server is now opened. You can see. So waiting for it to open fully. So we have this. It's all what I've done so far in my working directory. So I'm going to look for time series so that I can continue to work from there. This is it here. You double click and then it will open. Okay, so we have it. That's open. In our last class we looked at forecasting time series using a Riemann model, and then you did perform data cleaning respectively, and we predicted, and then we have this, and thereafter we look at trend detection. Okay, so look at trend detection using moving average, and we could study the pattern, the trend at which it moves. So today we'll be looking at seasonal decompose time series. Seasonal decompose time series. I want to restart this so that all of my variable will be active. Okay, so we have this. So for seasonality, it tends to compare that monthly, quarterly, daily. It gives us their pattern. This is it here. First to pattern that repeat at regular interval. Pattern that is repeated at regular interval, such as it can be monthly, it can be quarterly, it can be yearly cycle. Okay, for instance, retail sales. All right, so if you are using this will help you to take decision. For instance, during Harmattan or cold season, you know that, or winter as the case may be, that cardigan is usually expensive. So you can study that pattern. Okay, at this particular period, these products are on high demand. You get it? So that is it. So we use these kind of examples of time series research, and it uses additive model. We see that while decomposing uses multiplication. All right, so can we move on now to our environment? So it's not, I have to correct this. Where is it here? It's seasonality, not season. Let me quickly correct it. Not seasonal compo. Okay, quickly correct this. Seasonality. Okay, okay, yes, okay. Let's delete this. Ctrl Z. Seasonality. All right, this is it. So we move on now. I will be using the same data set that I used here. Uh, this. Okay, we have performed this already. This, this, but for the sake of the class, I'll just copy this and then move. Okay, copy and move here so that we can import directly. Okay, so for those who are joining us for the very first time, we have passed this data set monthly CSV file using pandas. If you have not done that, look at where we imported our pandas earlier on. Look at the we imported our pandas as PD, this start model, arima model, that's for this. Then we imported matplotlib. So for the part that we are using the same environment, I don't need to re-import these libraries again. Okay, as long as I'm working on this environment, so I can easily make reference to the imported libraries. So we have this. Next thing we are going to do is to import the libraries that will be used in the decompose seasonality. Okay, rather. Okay, so we have this statsmodels.tsa dot seasonal. Then we are importing seasonal decompose. Okay, seasonal decompose. So this decomposes the time into trend, seasonality, and residuals. And I said something that we'll be using additive model here. For decompose, we're using multiplication, multiplicative. When we get there, we call remind us again. Okay, so this is the model for this. It is important that we import it, and it is found here. So let's make reference to it. We have result is equals to seasonal decompose as stated here, and then we have sales. Sales, I have to close it. The model is equals to additive. Additive. Okay. So as I said earlier on, you see we have the additive model here. Okay. The next thing is to plot. Not exporter. So it's going to be results dot seasonal dot plot. Okay. So okay. Then next thing is PLT from our matplotlib library show. All right. I can add the legend to it. PLT dot legend. All right, let's run and see. Let's wait for our result. Bravo. So you see, we have our result here. You can see the pattern. This is yearly, right? No longer monthly. You can see we have 1960, 1961, 1962. If you study this pattern, you see it's almost the same pattern. It's almost the same pattern. So this is so yearly. This is they're almost having the same thing. So at the middle of the seems the demands of the sales the sales usually go down. Okay, so that is that about time seasonality time series. I would say it is used to measure the seasons or trends. Okay, either quarterly, yearly, or monthly, as the case may be. All right. What we have to do is decompose. We'll skip this and do this for now. This one, this one. Okay, I guess you can see it. Decompose time series involves separating data into its trend. The other one did not actually separate them, it just shows the pattern. That is for the seasonality. However, for the composing time series, it separates the data into trends, seasonal, and residual, that is the noise component. This is helpful in understanding the different underlying factors in a data set. Okay, and it uses the same libraries with the seasonal, that is seasonal underscore decompose. However, the model for decompose is multiplicative. Okay, so let's come back. So we can change this now. This is decompose time series. Okay, so um, can I just copy this? Let me just copy this, and I will edit the data set. Okay, we have this now, the same data set, TSA seasonal and post-seasonal decompose. So we say this one is then multiplicative, multiplicative, and this one now is results. Okay, this one should be result dot plot. So I've changed it to multiplicative. Now you notice I remove the seasonal. Plot decompose. Let's change this. Decompose. All right. Let's run this and see what we're going to have. Okay, no handles with label font to input legend, no problem. So if you look at this, there's no need for legend. Unlike uh the seasonal, we have season is showing that okay, seasonal. Look at it here. Okay, you can see. So we have it has divided the sales now into four. Look at it. We have the sales from 1960 to 1968. Look at it. It was moving this way, splitted, then up. Then as at this 1962 towards the middle, it was up this way, this way, this way. Now you can see our sales. It was rising. The trend, now look at the trend. We have this that is ascending. Then the seasonality, just like the one we have there. Look at the pattern. We have the same pattern you can see. Then the noise, that is the residual. You can see. Okay, so do we have outliers? All of them are almost at the same point. We don't really have any outliers. So let me remove this now. So you agree with me that the compost time series covers both seasonality results and other things. Okay, so this basically explained it into trend, seasonality, and residuals. Okay, so we can now move on to check for anomality and autocorrelation. Okay, let's check here. Okay, so I guess we can come back to this now. So there is an anomalies or outliers. So For this, usually it indicates unusual behavior such as fraud detection, equipment failure, or sudden market movement. So, and then we are going to use a server data. I'm not going to import, I'll just uh, write a code. Okay, so I'm going to show you how to do that. Okay, so let's go on. So we're going to change this now. It's anomalies section. I'm going to be using a server request, and I'm going to import uh, NumPy and other libraries. So I'm using a NumPy now to make a random seed starting from 0. Okay, so I said we're using a data from server. Okay, so this is how I want to import it. NP, that is from NumPy, random seed, and then I'll declare my date using PD, the date range, at least starting from January 1st, 2023, period for 352 days, and then the data using NumPy to random.normal, location LOC 100, the scale is 10, and the size is 352 as well. Then the data as well 50, that's where we introduce some anomalies. 50 ratio 52 200. So we have this. Then we now pass all this now into our DF. PD the data frame contains the data, index dates, columns, that is the requests. What we are doing is to use a z-score. Now, for you to be able to detect anomalies or outliers, you can use a z-score for such purpose. You can also use rolling statistics. So, for the purpose of this work we are doing, I'm going to use z-score, and then z-score is equals to df, that is df request, this request here, you can see, dot the mean. I've gotten divide by this minus this dot mean, divide by request dot standard deviation. The next thing is to then plots. So plot anomalies, we plot the scatter, plot the z-score. So we have the request dot plot, we have anomalies, that is df z-score, abstract greater than 2, that is a condition. Then the scatter plots, we have a plt scatter, anomalies as index, anomalies, then our request. Then we say she colored it red. We have plt dot legend, and then we have plt dot show. Let's wait for our results. All right, bravo. You can see we have this red point is the anomalies, then this other lines is the request. You can see this is from January to December. We can reduce this period to 90. The size to, let's change it to 90. That is 90 days. So it's my results. Okay, if you look at it, you have January, February, March. You see it. So the requests, and so if you look at this, is on this point here, February 20 something, and to February 2027 or so, or let's say 19 to 27 or 26. That was when we have the anomalies. From here, there is no anomalies. So if you can look at it, okay, so you can easily select your period. Like here we're using 90 days, and then the well, this is where we introduce the error between 50 to 55. So that is how to identify anomalies or outliers. Now let's see if we can get a data set for this purpose and run. See if we can get something done with it. Let's try. So we're going to use the same data set, the monthly sales here that we've been using, monthly sales for the next analysis. That is the same the anomalies detection analysis. Okay, so let's go ahead now and import a library. Since I've been using matplotlib and pd, so I guess I can leave that. Pd dot radius, yes, file, and name of the file, monthly sales, right? Dot csv. Let's confirm. Not for this, the other one. Okay, monthly sales dot csv. Okay, okay. The next thing we're going to do is to pass our date, that is the month, into date. Then we set it. So we have month, pd date time, that is month. Then we set the index to be month in place. It's true. Okay. So the next thing now is to use our z score. We say we're going to use our z score. Okay. So for the z score, let's go ahead and set it. We have a z score. This df sales. That's the second column in that. And then we have uh okay, that is sales minus sales dot mean divided by sales dot standard deviation. Okay, that is the formula to calculate a z score. Okay, so now we're going to set the threshold, right? I don't know if this is correct. So 2. Okay, we're going to set our threshold to 2. Okay, let's go ahead. So you can say it's equal to, that is it. This set threshold to 2, that is for our anomalies. That is at any point it identifies at any point that our z score, okay, is greater than this threshold, which is 2, it means there's an anomaly. Okay, so we're setting it to be 2. So we said df anomaly, okay, is equal to df z score. Okay, dot abstraction method if it's greater than this threshold. If this z score now is greater than the threshold, which is 2, then it means there's an anomaly. Do you see it? That is the formula. If this z score that we have here, you see I've highlighted it. If it is greater than 2, there is an anomaly. Okay, that means there's an error. Okay, so the next thing is to plot. Next thing is to plot. Okay, the plot anomalies. Let's go this way. Anomalies. Okay, so now we have this the figure that is x, then y, then that is the size of the figure. Then we are plotting sales. Okay, the label is also sales. Then scatter plot, that is the df, the value, the variable holding our data set. Anomaly dot index. Then we have anomaly. We have it to be with sales color red. That is the index. That is the month. If you do not forget, look at our index here. Month. That is our index. Okay. So we have it to be uh, months. It's getting scatter plot for the month. That is the index and the sales. So the color to show that there's an anomaly is red, and it will label anomaly, and the marker will be X. Okay. Tied to anomalies detector using Z score. Okay. Then the X label, we have this. Okay. Then let's add this plt dot legend plt dot show. Waiting for a result. We have error somewhere. There's error somewhere. There's error somewhere. Okay, let's see how to correct it. Okay, we had a mistake. Look at it. We wrote CVS instead of CSV. Let's correct this. Let's see. Bravo. You can see we have it. We have it. We have it. You can congratulate yourself now and shake. If you're with your colleague, shake hands with your colleague. You can see we have our results, and we was able to detect two anomalies, one here and one here. All this means they are greater than 2. That is our sales. You can see there is this and this. Okay, we have to change the threshold. You can see if that's as well, we change our threshold to 3. Let's run. See, we don't have any anomaly. Okay, let's change the threshold to 1. Okay, so look at it. We all have anomaly everywhere. You see, you see, you see, you see, you see, you see. All right. So that is how to detect anomalies. In case the data sets you are working with is in a CSV, then and you have to read it into your Jupyter notebook. You just have to go through the dates. You convert the dates. Okay, you set index for it. Okay, then you can then go ahead to use your Z score. All right, then your Z score will then be used to compare with the threshold. Once it is greater than the threshold value, then you can see there's an anomaly. All right, all right, all right. So let me change this back to 2. All right, let's run this. Bravo. Okay, okay. So we're done with this. The next thing we are going to check is autocorrelation. Before we go to there, let's look at autocorrelation and smoothing. All right. So we're still going to use the same data set for the purpose of this class. This, okay. All right, okay. Or I can see some of you are already tired. All right, what is there? In the next class, we'll consider the 2 other time series analysis, okay? All right, if this is the first time that you're joining the class, I want to advise that you do well to subscribe and invite others to follow suit. If you have any question, you can always come to IDM for more clarification. All right, the dataset can be gotten from Kaggle. Just search for monthly sales. right? You're going to have the data set and then you can use it to practice. Thank you for listening. See you same time and same venue.